Hello, good evening, Andrew. Good evening, everyone. My name is Hong Qian. This is my oral presentation. Couple years ago, I was on holiday in Tasmania. Tasmania is a very nice state in Australia. Uh, Hobart is the economy, culture, and transportation center of Tasmania. Hobart has very beautiful weather, fantastic seafood, uh, and very nice clean air. I spent a couple days in Hobart. Uh, so this time, I use all the Hobart photos as the background. It's lucky this time. I choose Hobart as the subject of my climate research. Because human activities destroy the natural environment, the climate is getting worse and worse. Flood, storm, dry season always happen. We need to protect the natural environment. In the future, we will expand sustainable community and green star houses and buildings. We also plan to build wind power farms to generate uh, green energy. So this time we need to get Hobart weather information from Bureau of Meteorology website. Then we need to analyze all this data for the future feasibility report. First, I stored all the data in the Excel. I deleted some information that we don't need. Uh, I only keep the maximum temperature, maximum daily temperature, rainfall, maximum wind speed. By the way, I renamed each Excel file and put all the file into one folder. Second, I use for loop function to extract all the data from Excel to MATLAB. Each Excel file have relative MATLAB file. I use the switch case function to do the calculation and subplot 12 months daily maximum and minimum temperature on the same graph. Then I use if function to calculate the total number of comfortable days. Now we do the task 2. In task 2, I put all the months rainfall data together, then plot daily rainfall graph. Use for and if function to calculate numbers of days with no rain, normal rain, heavy rain. After we get all the year's total rain value, just multiply the area of the house, then multiply water price. Uh, at last, we can get how much money we can save every year if we use rainwater collect tank. Now we do the task 3. In the task 3, first I put maximum windy speed data together. We generate all year's windy data. Then plot the graph. Follow the wind power curve. I get two equations. Then I use for and if function, calculate the wind turbine's daily power generation. Then I bar plot the graphs for the wind turbine daily power generation capability. At last, I highlight the days with the wind speed greater than 100 kilometers an hour or less than 13 kilometers an hour. After we analyze all the weather data, we can find out that Hobart has a gentle temperate oceanic climate. The highest temperature recorded in last year was 37.5 degrees and the lowest temperature was 1.8 degrees. The average daily temperature in summer are between 17 and 23 degrees. Hobart has nice cool summers and genial winters for its location close to Antarctic, and it is greatly affected by seaside location. I give some suggestion. If you want to have a nice holiday in Hobart, you'd better visit there in summertime. Rainfall is not enough in Hobart. Last year, total rainfall value is around 617.8 mm. Rainfall is evenly distributed throughout the year, but winter is the wettest season. In order to save the water, many houses should be equipped with a rainfall water collection tank. One house with 90 square meter, every year it can collect 54 kiloliter water. In fact, we didn't save much money, but we saved plenty water. Hobart is located by the sea, so it have a rich wind source all the year. Maximum wind speed is greater than 13 kilometers an hour. Only 2 days is greater than 100 kilometers an hour. So we can build wind power farms there to produce green energy. After we analyze the Hobart's weather data, we can develop industry according to local climate character. For example, we can develop tourism, viticulture industry, aquaculture industry. With the development of Hobart's economy, we need more and more electricity, but we also need to protect local environment, so we should develop wind power farms. In my idea, the maximum wind speed does not mean that this data can be used to calculate the daily power generation of the wind turbine. We should use the average wind speed to calculate the power generation. We also should consider the duration of the wind every day. That's my oral presentation. Thank you.